So now we've learned a couple of things about injectors. We've learned the hierarchy of injectors, and we've also learned how each consumer traverses this hierarchy to retrieve its requested resource. But what we've learned is the default traversal of a consumer. We also have at our disposal ways to modify this traversal. A resolution modifier is an instruction which changes the way a consumer traverses the hierarchy of injectors. There are 4 resolution modifiers, and each of these modifiers is an angular decorator. We first have the optional modifier, which prevents the throwing of the no provider error that is thrown when a consumer traverses the hierarchy and reaches the null injector. Next, we have the self modifier, which instructs the consumer to look no further than its own array of providers in its own component or directive decorator. Next, we have the host modifier, which instructs the consumer to look no further than either its own providers array or the providers array of its hosts. The last resolution modifier is skip self, and this modifier instructs the consumer to begin looking beyond its own array of providers. Let's take a look at how each of these resolution modifiers works in our demo application. Back in our demo application, I once again have both of our components using the display service. Both the display component and the other component are using the display service, and they're both using the display service that's registered in the root injector, because neither of the components has its own providers array that contains a registration of the display service. So both components are using the root level display service. And notice in the browser, everything is working perfectly. Now, if we remove this provided in property from the display services injectable decorator, like so, of course, we get the no provider for display service error. And that's because for both of the components, for both display component and other component, they're both reaching the null injector. But we can use the optional resolution modifier to prevent this error. And the way that we use the optional modifier, we decorate the display service parameter in each of the components constructors. We decorate them both with the optional decorator. So I'll make that change here in the display component, and I'll also add the decorator in the other display component. Get this import. And now notice we no longer have errors in our console. Now be aware that when you use the optional modifier, any usage of the resource in your code has to be wrapped in a condition in an if statement. And that's because if the consumer reaches the null injector, then the service is still null, and any retrievals of properties and methods on this service will produce a null object error. And we can see that if I remove the if statement from around the use of the service, we see that cannot read properties of null error in our console. So be sure to use a conditional with your resource whenever you use the optional modifier. Now let's take a look at how the self modifier works. I'll first put back the if statement in our other display component, and I'll also put back the provided in root property. Let's remove the optional decorators in both components. And now we're back to the scenario where both of our components are using the singleton instance of the display service that comes from the registration of the service using provided in. Now we know that this is a singleton, and the way in which we can prove that is the update source button that's being shown in each component. It's actually modifying the state of the display service. Each click of the update source button runs the change info method on the service. and that change info method emits a new value to the service. So if I click on any one of the update source buttons of any one of the components, notice what occurs. The state is changed in all of the components, or at least both of the components. And that's because they're sharing a single instance of display service. So when the state of display service gets changed, it's changed for all of the consumers. Now, what if you don't want a single instance of the display service? That is, you want each component to have its own instance of display service. Well, that's where the self modifier comes in. Let's now add the self modifier to each of the parameters, constructor parameters, in both of our components. So I'll add it here in the display component. I'll copy this and add it to the other display component. And look what occurs. We get an error in our console. We're getting that no provider error in our console. But why is that? We still have the provided en route property in our display services injectable decorator. So we have a registration of the display service in our hierarchy of injectors. Why are our components reaching the null injector error? Well, in actuality, they're not reaching the null injector error. They're reaching the node injector error. When we use the self modifier, we're mandating, we're requiring that the service be registered within the providers of the consumer. So in this instance, we're on the other display component, and we have the self modifier decorating its constructor parameter for the display service. That means that the display service must be registered within the other display components providers. The self modifier prevents traversing any further in our hierarchy of injectors. And because at the moment there is no provider for the display service within the other display components providers, we're getting this node injector error. We're actually getting it for both of our components. We're getting it for the other display component, and we're also getting it for the display component, because the display component also has the self modifier and no provider or registration of the display service within its components. So to fulfill this modifier's requirement, we have to register display service within both components providers. So let's do that. I'll do it first here in the display component. We'll add display service. And notice now we only have the error for other display component, but if we go to display component and also add a registration for display service, now the error goes away for both of our components. And notice another thing that occurs. If I click the update source button here in the nested other display component, watch what occurs. Now each component, each use of the component is getting its own display service instance. So changing the state of its instance of display service does not change the state of the other components. And if I click the display component update source button, notice its state gets changed, but its sibling other display components service state does not get changed. So essentially, each one of these usages of the components is getting its own display service, and they're all fulfilling the mandate that the self modifier is making. Here's a point that I want you to understand, because it might have occurred to you that even if we don't use the self modifier, we're going to get individual instances of the display service being created by virtue of the fact that we've added the registration of display service for each component, which means if I remove the self decorator from each of these components, and I'll remove it first from other display, and I'll also remove it from display component, I've removed the self decorator, but we're still going to get individual instances of display service for each of these components. If I click on update service within the nested other display component, it's only impacting the state of that component's display service. The same goes for display component and the sibling other display component. They're still getting their individual instances of the display service, despite the fact that we no longer have that self modifier here. But what does this tell us? Well, the self modifier can be used at the discretion of the developer or the development team, because what we're really doing by using the self modifier is we're saying that it's not optional that each component has its own instance of the service, the resource. We're saying that's not optional, it's required. And if you don't do it, you're going to get an error. So if I put back the self modifier on each component, yes, everything will work if the registration happens at the component level. But the moment I don't register the resource at the consumer level, I get this error. So really, the use of the self modifier, it's more about sending a message to other developers. And typically, you will use the self modifier when you have a resource, such as a service, that has state, and you don't want changes to the state of the resource to propagate throughout your entire application. You want it to be contained within a given component. That's when we use the self modifier. Before we begin investigating how the host modifier works, let's first get our demo application back to its original state. So I'll remove the providers from each component, and I'll remove the self modifier from each constructor parameter. So now, once again, each of the components is getting its display service from the root level injector. And again, we can prove that by clicking on one of the update source buttons, and notice the state change is made to all of the components. So again, we're using the root level display service, and it's a singleton service. Now let's discover how the host modifier works. And it works a lot like the self modifier. So let's first add the host modifier to the constructor parameters in both our components. So I'll add it here in the other component, and I'll add the import, and I'll copy this and add it to the display component. And I'll also add the import here. And by adding the host modifier to both components, again, we see the no provider errors, and we see that they're being found in the node injector. So this is working a lot like the self modifier. And as such, of course, if we add the registration of the display service to both components, the error will go away. So let's do that for both components. I'll add the provider here in the display component, and I'll also add it in the other display component. And now we see that the error goes away. And in the same way, when we had the self modifier, if we now click on any one of the update source buttons, we see that the state change to display service only happens within that component's usage. So again, we're back to getting individual instances of our display service. And again, we're getting those individual instances because we are registering display service within each of our components. So again, it's the same phenomenon. The host modifier is really mandating something. It's not controlling the number of instances of our resource. It's mandating that the resource has to be registered in a specific place. Now, how host and self differ, you've probably guessed by the name. But to better see how the host modifier differs from the self modifier, I'm going to make a slight change in our code. I'm going to go to the app component and I'm going to comment out the sibling instance of the other display component, and I'll maintain the nested or child instance of the other display component. So now let's go back to our component code. Specifically, let's go to the other display component and let's comment out the registration of display service in the other display component. Notice we don't get an error. The other display component is finding a registration of the display service. Display service is not registered in the other display component, but it is registered in its parent. The host modifier differs from the self modifier in that the host modifier allows the traversal to go one level higher. It allows the traversal to go to the host element. And what that means is if the resource is not registered within the providers of that component or directive, the host modifier will allow the traversal to continue up to the host component, and it will stop at the host component. So now I have to show you exactly what's meant by a host component. And that's why I commented out the sibling other display component. So just to reiterate, on the other display component, we don't have a registration of display service on that component, but we do have a host modifier on the constructor parameter of the display service. So because we're not getting an error, we know that the other display component is getting its resource from its parent display component, the component in which it's nested, because there we have a registration of display service. But notice there's also a host modifier on the constructor parameter for display component. Now let's see what happens when we remove the registration of display service from display component itself. And I'll just comment this out. First I'll copy it and I'll comment it out. And of course, we get the no provider error. But now let's go over to the app component. And remember, the app component has the display component on its template. But let's add the provider of display service. Let's add it to the app component and see what occurs. And notice we still get an error. And actually, let's go back to, for a moment, let's go back to the other display component and let's remove the host modifier from other display component just to ensure that that is not causing this no provider error. And we know that it's not because we're getting the error on the display component, but I just wanted to make you aware that this error is not coming from the other display component. So what does this tell us? This tells us that the display component, while it's on the template, it's not being hosted by the app component. And I want to make you aware of that because we're going to see shortly that there is another way of providing for things that are on templates. But what we're seeing is that the display component does not have a registration of display service on itself, on its own component, and it has no host component that provides the display service. The app component is not the display component's host. However, we do see that the display component is a host of the other display component. And if we put back the host modifier, and for the display component, we add back the provider, the registration of display service, everything works. And everything works because other display component, while it's not finding the registration of display service in its own component, it's finding it in its host component. And display component is finding its registration of the service in its own providers. So the host modifier looks first to its own component or directive for the registration of a service, and then it will look only to the host of that consumer, and it won't look any further than that. So self stops at the component or directive level itself, and host looks at both the component level or directive level, and then one level higher only in the host component level. Now, it's easy to see for components what constitutes a host. In the case of other display component, a host is the component into which another component is projected. And if we go back to the app component template, we see that other display component is projected into the display component. It's not on the template of display component, it's projected into display component. When it comes to directives, the host of a directive would be the element on which the directive sits. So if we had, let's say, a display directive, display component would be a host of display directive because display directive sits on the display component element. So if we added the host modifier to display directive would first look at its own providers in its directive decorator for display service. And then if it didn't find it there in its own providers, it would look to the providers in the display component. So that's the way in which directives find their hosts. Now, before we go on to skip self, the skip self modifier, I'm just going to clean up the code so that we add back the other display. And we'll go here to the other display component and let's remove the provider here. Let's also remove the host modifier and let's go back to the display component and also remove the providers there as well as the host modifier here. And now we're back to the original state of our code. So now let's talk about skip self. And as you might imagine, skip self skips the component or directive level of the consumer itself. And the way in which we can illustrate this is let's add the skip self modifier to display component, and let's also register display service here in display component. And it kind of looks as if everything is working as normal. But what I'll do is I will click the update source button here on the other display component that's a sibling to display component. And let's see what happens. Did you expect that? The state of both sibling components has been changed. That means that both of these components, both the sibling components, are using the root level registration of display service. Display component is using the root level instance of display service despite the fact that it has its own registration of display service. So the skip self modifier moves the start of the traversal of the injectors from the component or directive level of the consumer. It moves it to the next higher place in the traversal. And in this instance, display component finds the registration of display service in the root level injector. Before we end this video, I do want to mention that resolution modifiers can be combined. Specifically, we can combine the optional modifier with any of the other 3 modifiers. And we do that to prevent the no provider errors that we see from both the null injector as well as the node injector. Now, I'm not going to show you any examples of combining resolution modifiers. I'll leave that to you to explore. Stay tuned for our next video, which will also be our last video in the dependency injection series. And in that video, we're going to discuss view providers. View providers are an array of providers that are present in components. And thus far, we've only seen the providers array. So in the next video, we'll cover the view providers array. We'll also take a look at services, because services can also be consumers of other services. But unlike components and directives, services do not have their own providers array. But services, because they can also have resources injected into their constructors, they too are impacted by the hierarchy of injectors. So we'll take a look at services. And one other thing that I'll cover in the last video is use cases. Now, we've covered a lot of features in dependency injection, and you might be wondering, under what conditions would I use a resolution modifier? Why do we have varying places where we can register services within the Angular ecosystem? So I'll talk a little bit about that as well. But for now, I hope you found this video in the dependency injection series. I hope you found it really helpful, and I look forward to seeing you in the next video.